Maths Master Class, grade 12. Today we're doing mathematics, focusing on quadratic, arithmetic, and geometric sequences. By the end of this lesson, you will be able to calculate the nth term or the general term. You will be able to calculate the position and able to find the position of the term as well. So you'll be able to distinguish between the quadratic, arithmetic, and geometric sequences. Right? Okay, let's start. We're going to start with quadratic sequences. What is quadratic sequence? A quadratic sequence is a sequence in which our second difference it is constant. The second difference it is constant. What do we mean when we say our second difference is constant? Let me take you through an example. What do we mean? So we're going to look at the quadratic pattern. It has the first difference and the second difference. So before we can get the second difference, we're going to look for the first difference. How do we get the first difference? We're going to say term number 2 subtract term number 1, right? And then that will be 6. Am I right? And then we'll say term number 3 subtract term number 2, and then that will be 10. And then we'll say term number 4 subtract term number 3, that will be 14. This is how we get our first difference. So this we call it our first difference. Call it our first difference. Am I right? So now we have to look for the second difference, and the second difference, it must be constant. When the second difference is constant in this case, then that will be our quadratic equation. Am I right? Okay, let me take you through, and then we're going to say 10. We're going to say 10 subtract 6, that is 4, and then 14 subtract 10, that is also 4, right? Okay, and then this is what we call our second difference. Our second difference. Thus, the given pattern up there is a quadratic pattern. Why? Because our second difference, which is this, it is constant as defined up there. So now we can conclude, and we're confident that the second difference is constant. Thus, it's a quadratic equation. Okay. So now let's explain the formula. We have the formula Tn is equals to an squared plus bn plus c. So what it is n? What is this n? What does this n mean? Oops, sorry. What is this n? This n is the position of the term. For example, let's go back to our quadratic equation. We have 5, which is in position, it's in position 1. So when 5 is in position 1, that simply means n is equals to 1. It's in position 1, and n will never be negative. The position of the term can never be negative. And then how do we represent it? We're going to say term number 1, it is equals to 5. Right? Yes. So 11 also. Let's look at 11. 11 here is in position 2. Therefore, our n will be equals to 2. And then how are we going to represent it? We're going to say T2 is equals to 11. Term number 2 is equals to 11. Right? So going forward, how do we get this value of a? A value of a is a constant. It's represented by a number. So how do we get it? A is equals to our a is equals to half of the second difference, and we have found our second difference up there. We got our second difference, which is 4, right? Okay. So now let's look for the value of let's look for the value of a. How do we find the value of a? We'll say a is equals to half of the second difference. So our a is equals to half of the second difference. What is our second difference? Our second difference in this case will be 4. So we're going to substitute 4. Our second difference is 4. And then what do we get? We get half of 4 is equals to 2. Am I right? Okay. Going forward, that's how we get the value of a. Right? So our a here in this equation, it's 2. Right? Our a in this equation is 2. So that's how we find the value. So we're going to replace a by 2. Okay. So how do we get the value of b? How do we get a value of b? Also, b, it's represented as a number, and then here it's the formula that can help us to get the value of b. Okay. Let's take a look. We're going to substitute into that equation. So it's 3 into what is the value of a? The value of a is 2 because we've calculated it above. Then we're going to say 2, and then we close our bracket. And then it's plus b. This is how, remember, we are looking for b. This is how we find the value of b. Okay. And then which is equals to T2. What is our term number 2 here? Look at the formula. T2 here we found our value of T2, which is equals to 11. That's term number 2. That's 11. And then subtract. What are we going to subtract? We're going to subtract T1, which is 5. Right? Okay. And then 3 times 2. In this case, it will be 6 plus B, which is equals to 6. Right? Which is equals to 6. So now we're going to subtract 6 from both sides. Or you can take 6 to the other side. Then we'll have B equals to 6 subtract 6. Then that will be 0. So in this case, our B is 0. So now, how do you get the value of C? We look at the formula again. This, how do we get the value of E? E is also represented as a number. C, I mean to say, sorry. C is also represented as a number. So we're going to write down A. We got our A up there. We got our B up there. Now we're looking for the value of C. Okay. How do we get the value of C? So we're going to substitute. What is our A? Our A, we got it up there, which is 2. And we're going to say 2 plus B is 0. And then plus C, which is what we are looking for, which is equals to the first term. The first term is 5. So what will be our value of C? 2 plus 0, it's 2. And then we take 2 to the other side. And then we'll have 5 subtract 2, which is equals to 3. So this is how we get our values of A, B, and C. So in this case, we got our B. And our B is 0. And then we have our C here. Our C is 3. So now we're going to write the nth term. Right? So how are we going to do it? We're going to say Tn is equals to ax squared plus bn plus c. So now let's replace a, b, and c, because we found the value of a, b, and c. So our Tn will be equals to, what is our a? Our a is 2n squared plus 0n, which is going to be 0 plus 3. So 0 multiplied by n, that will be 0. Then we'll have Tn equals to 2 squared plus 3. So this is our nth term. This is our nth term, or the general term, of this sequence. Right? So that's how we find our general term of the sequence. Going forward, let me take you through an example of quadratic pattern. Okay. There we go. Oops. Okay. It's from a previous question paper. Let me just take you through this example. I hope after this example you'll be enlightened. Okay. We are given a pattern 5, -4, -19, -40. So now we're given a quadratic pattern. So we have to find, is it a quadratic pattern? What do we have to do? We have to find the second difference, and then our second difference must be constant. Okay, let's take a look. So we're going to say -4 subtract 5. -4 subtract 5, that will be -9, and then -19 -4, that will be -15, right? And then let's go again, -15, and then -40 subtract 19, that will be -21. That will be -21, right? Okay, this is our first difference. This is our This is our first difference, and our first difference is our first difference, right? So now let's take a look and then see if our second difference is constant. Okay, and then -15 minus subtract -9, that will be -6, and then -21 subtract -15, that is also -6. This is our second difference. This is our second difference, and our second difference is constant. Therefore, we can conclude that this is a quadratic. This is a quadratic equation. Right? Okay. Now let's take a look at our question. Let's start with 2.2.1. Right? Let's start with 2.2.1. Now determine the constant difference of this sequence. What will be the constant difference of this sequence? We found it here. The constant difference is the second difference, which is -6. So our constant difference will be -6. All right? Okay. So now let's go to 2.2.1. 2.1, and then now determine the nth term of the pattern. How do you calculate the nth term? You look for here is the general formula for the nth term. Tn is equals to an squared plus bn plus c. And then how do we find the value of a? A is equals to half of the second difference. Our second difference is minus 6. You substitute, and then we get minus 3. Am I right? Okay. And then we're going to look for the value of B. We're gonna say 3 into A from the formula in the first slide. What is our A? It is minus 3, and then plus B, which is equals to T2 here. Our T2 is minus 4, and we substitute there minus 4. T2 is minus 4. Substitute there minus 4, and then subtract our T1. Our T1 is 5. Okay, and then we're gonna say 5, and then we'll get 3 multiplied by minus 3. That will be minus 9, and then plus B. That will also be equals to minus 9, and then our B will be equals to minus 9 plus 9, which is equals to 0. All right. So we got the value of B. Now let's look for the value of C. How do we get the value of C? Right. Okay. C it's equals to A plus B plus C, which is equals to T1. We found the value of A up there, which is minus 3, and then the value of B is 0 plus the value of C. We're looking for the value of C. All right. And then what is our T1? Our T1 is equals to 5. All right. So we substitute there, it's equals to 5. And then you add C, minus 3 plus 0, that is minus 3. And then you add minus 3 both sides, then we'll have C is equals to 5 plus 3. That will be equals to 8. Right? Okay. Now, remember we are looking for the nth term. So now, in this case, we're going to replace our A with minus 3, our B with 0, and then the whole thing will be 0, and then plus 8. Okay. Now, let's write our general equation. Okay. Then our Tn is equals to, what is our A? We found our A to be minus 3. Then it will be minus 3 n squared. And then what is our B? Our B is plus 0n. And then what is our C? Our C is plus 8. So now this is equals to minus 3n squared plus 8. Right? Perfect. So now let's move to 2.1.3. Which term of the pattern will be equals to minus 2593? Which term? Am I right? Which term will be equals to that? So we're going to look for the position of the term so that we can find the term in which will be equals to minus 25939. Am I right? So now we're going to say which term. Am I right? Which term? Tn is equals to minus 25939. Remember what we're looking for? We are looking for the term. Therefore, we're going to look for n in this case. So now we're going to use the same equation of up here to get our position of the term. Am I right? Okay. Let's move forward, and then we're going to substitute that. Our Tn is minus 3n squared plus 8, which is equals to minus 25939. Oops, sorry about that. Okay. So we take 8 to the other side. Taking 8 to the other side, that will be minus 3n squared, which is equals to, then you add, it will be minus 25939 minus 8. And then that will be 25 minus 25947. Right? Okay. And then we're going to divide both sides by minus 3. Remember, we're looking for divide both sides by minus 3. Remember, we're looking for n, position of the term. Just divide this to be 1, and then now we'll have n squared. We'll have n squared to be equals to minus 25947 divided by 3. That will be positive 8649. 8649. Am I right? So now we're going to square root both sides, and then we'll have, in this case, we'll have n is equals to plus minus the square root of 8649. Right? And then that will be equals to plus minus 93. Remember, our n can never be negative. The position of the term will never be negative. And then therefore, we're going to say n is equals to 93. Right? So that will be T93. That will be equals to minus 25939. Right? Okay? Going forward, now we're moving to arithmetic sequences. Thank you for watching Mathematics Mathmaster Plus video. Please subscribe to our YouTube channel.